So what are you looking for once you plug in both sides of the equation into Desmos? Nope. Guys, look at the front page of your paper. Just the front page. I'm reviewing. So if we're solving an equation using Desmos, what am I looking for? The points of intersection. So we're looking for the points of intersection. What part of the points of intersection do I use though? The x values. All right, you need to know this. This will save your life on the EOC. Trust me. Now, so the last thing we had to talk about, this is number 5, was regression. All right. So here's the great thing about regression or best fit equations. You don't just need to do it. It doesn't only work if it's just it asks you to find the line of best fit. All right. If they ask you to find an equation from a table, you can also use regression to do that. It'll just give you the exact answer instead of an approximate. All right. So, especially those questions where it says, find the slope of this table or the constant rate of change of this table. I would make a regression table in Desmos and get the slope from the regression equation. All right. Because it would be exact. So, remember, whenever you're doing anything dealing with regression or line of best fit, depending on what it's for, linear, quadratic, or exponential, you got to determine which model fits the best and then round to do 2 decimal places if necessary. So remember, this is what you plug into Desmos after your after you plug in the table. So linear, exponential, and quadratic. All right, these are what you need to memorize. They're the basic forms. Because on y'all's version of Desmos on the EOC, so the normal version of Desmos has that little regression button that you can click and select which ones you want once you put in the table. The EOC version does not. All right, so you gotta know these 3 equations. If all else fails, when you get that scrap sheet of paper for your EOC, jot those down first thing you do. All right, so you know that's what you have to put it into your calculator if you need it. Now, all else fails, put it in the TI. You have access to a TI as well. But we all know that Desmos does a little bit more with regression without having to know a bunch of different steps. Button steps, anyway. All right. So all else fails, if you completely forgot what to plug in to Desmos, do it in your TI. Because remember, that's just anything dealing with stats. And remember, we always hit the stats key, input the table, and then it's just like finding the 5-number summary, but you just click the different type of regression that you want. All right. Now, they went ahead and inputted in this example. So even though they have a picture of it, let's go ahead and just put in this example together. All right. So take a minute, put that table into Desmos. Now, to recap, what do I click to add a table in Desmos? The plus button, and then I hit what? Table. All right. So take a minute, go ahead and type in that table that's in the example. All right, so we're typing in the example table. Now, they said that the best fit equation was a quadratic, but they didn't tell us which one to figure out. So we got to actually try all of them to see which one works. So what I'm going to do is that in each different cell, I'm going to type in each of these. All right. And I'm just going to put them in all at the same time so I can compare them. All right. So type in each one of these equations. So in other words, I'm going to do linear first. So y1 squiggle ax1 plus b. And remember, to get the subscript of 1, just type a 1 after the variable and it'll automatically do it. All right, so that's your linear. Exponential, I'm just going to do right below it. So y1 squiggle a times b all raised to the x1. And make sure that log mode's already engaged. Good. All right. And then lastly, I'm going to type in quadratic. So y1 squiggle ax1 all squared plus bx1 plus c. And again, the reason I typed all three in at once is so I can compare them to figure out which one's the best fit. So take a minute, put all of those in right now. Again, don't forget, you've got to type the 1 after the x's as well as the y. If you don't type it after the x's, it won't work. All right, now, who remembers how you can tell which one is the better fit? There's something that they give you in all of this little statistics thing that will tell us which one's the best fit. What do you think it is? R squared. So you can either use R or R squared. Now, quadratic does not have an R. So typically you just use R squared. Now, how do you know which one is the best fit if you're looking at R squared? It's whichever one is closest to 1. All right. So if we're looking at R squared for all of these, whichever one is closest to 1 is the better fit. Whichever decimal is the closest to 1. All right. So if you look at your R squared for all 3 of these, which one is the closest to 1? Quadratic. All right. So make a note on your paper that for best fit, look at R squared, and whichever is closest to 1, put the phones up, is the best. Phones up. All right. So you're looking specifically at R squared and you want it to be the closest to 1. So whichever one is the closest to 1. So if they ever throw that at you guys, like if they're asking you which one fits the best, that's how you find out. Now, this is also true for if you just want to find an equation. So for example, do you guys remember when we did the practice EOC and a lot of the questions asked you find the equation that matches this table. Do you guys remember that when we did that practice EOC? You can do a regression to get that equation. You don't have to do the math for it. The regression will just give you the exact equation. It's r squared, or r value would be 1, all right, because it'll be exact. So if you ever doubt yourself, if you're given a table and it's asking you to find a slope or a y-intercept or an equation from it, do a regression, all right? That's a little trick if you're in the calc active section and you don't remember how to find the equation from a table, just do the regression. It'll give it to you exactly. Now, remember, when we do write out the actual best fit equation, we're taking whatever our starting equation was, and we're taking our parameters that they gave us, so A, B, C, and we're plugging those numbers in for A, B, and C. And then we follow them by X, all right, wherever the X's are needed. So basically, they're the coefficients or the constants, all right? So that's why their best fit equation is this. All right, any questions? All right, let's do one more example together, and then I'll give you guys the other 3 to work on your own. All right, so let's do example A together. So take a minute. I want you guys to plug in the table for example A. So you can delete all of these. I would just go ahead and delete the table too, because if you just go ahead and add a new table, instead of x1, y1, it'll say x2, y2, which means you'd have to follow with x2, y2 in your equations. So I'll just delete the tables. So take a minute, plug in the table for letter A. Once you get your table, go ahead and plug in the 3 different equations as well, so that you can see which one's the best fit. So do the linear one, the exponential one, and the quadratic one. All right, does everyone have the table and all the equations in? If you need help, please raise your hand. Yep. Because we want the best fit equation. And this one, actually, no. They're all very, very close. But one fits better than the other. All right, so if we're looking at our r squared values, remember, we want the ones that are actually the closest to 1. Now, it could take a couple of decimal places to figure out which one is the closest to 1, because all of these are pretty darn close. All right, they're all at least in the 90s. Their r squareds are. All right, or 0.9. Now, linear is 0.9657. Exponential is 0.9476. So is exponential a better fit than linear? Yes or no? Which one's closer to 1? The linear. So we can throw exponential out. All right. Now, quadratic is 0.99143. Is that a better fit than linear? Yes. So we can throw linear out. So quadratic is the best fit. So if we round to 2 decimal places for all of our parameters, so A, B, and C, what would be my new answer for this? So we're doing quadratic. That's the best fit. So we're replacing A, B, and C in ax squared plus bx plus c. All right, so if we're starting with y equals ax squared plus bx plus c, we're going to plug in for A, B, and C, given what they gave us on our screen. So what do they tell me A is, if you round to 2 decimal places? So guys, if you round to 2 decimal places for A, what's my A value? It's on your screen. A is equal to what, guys? It's right here. Negative 0.06 x squared. What's my B value? (1.375). So we'll call it 1.38 x. What's my C value? Negative 7.317. So 32. So what I did is I took the values for A, B, and C, and I plugged them in here, including their signs. And then I followed them, if they had anything after them in terms of x, I followed them with that. So the A has an x squared on the end of it, and the B has an x on the end of it. The C's by itself. That's how you write out your regression equation. Now, here's also where regression equation comes in handy. It's not on this paper, but this is something you may want to note. All right. So, let me zoom out a little bit because you don't really need it for this. So if I zoom out a little bit, all right, Desmos automatically graphs your points, so your scatter plot, as well as your regression equation. All right. Now, that being said, you can also plot the residuals as well, but that's really only for linear. I mean, you could plot them, but it wouldn't be anything nice. So if I look at my residuals, like if I plotted them, zoom out. My residuals are obviously in a pattern, so it's not linear. That's all residuals tell you. But look at my regression equation. Let's say it was a word problem. and it asks me, based off of its best fit equation, what would the x value be when y is 200? What you would do, what you would do is in a separate cell, you would type in y equals 200, and then find the points of intersect and use the x values. All right, you can do the same thing if they say, what will be the y value when x is equal to, let's say 4. You type in x equals 4, find the point of intersect. All right, so that's where Desmos comes more in handy than your calculator, like your TI, when it comes to regression, because it already pre-graphs you for that stuff. And if they ask you questions given the predicted equation, which that's what the regression is called, that's when it comes in handy. All right. Because if it's saying like if this value is equal to this number, you can always type in x or y equals that number and find the point of intersect, just like solving an equation. All right. So that's another strategy that you can use with Desmos. All right. So what I want you guys to do is take about 5-6 minutes, find the lines of best fit for B, C, and D. So that last back page. So find the lines of best fit for B, C, and D on the last page. So everyone needs to be getting those regression equations. Equations. It's not really French, it's just French accent. Kyrie, I'm not that bougie. So guys, everyone should be finding those regression equations. So I should hear a lot of key clickings. Remember, you want it to be the closest to 1. If it's exactly 1, your R-squared value, then you got your answer. Write what it is and write the equation. So whatever the equation is, use as your guide, plug in whatever it says for A, B, C, whatever, into its proper spots, and then add the x's. Huh? After we finish this. Oh, we're almost done. She seems to do that a lot. So in other words, you just need to start calling her more Kyrie. I called her when I said.
And she was just getting ready, and I was like, "Where are you going?" She said, "I'm not going. I missed the bus." So then what's the point of being there? Remember when she got an Uber and then she was Uber? How do you miss an Uber? She didn't want to post it. So she missed the Uber. But I was like, what he told me.
How do you miss an Uber?
And she didn't know that she didn't want to come to school in Uber. And her grandma was there in taxi. She didn't want to come to school.
They both work. You can write both.
Calm down.
That won't happen on the EOC, but like it's just the example that they gave that 2 actually works.
So it was more, we're supposed to remember that. So we put in the
Well, yeah, you should already know what a linear and quadratic and exponential function looks like. So it's actually not anything hard because linear is just slope intercept. Quadratic's just its standard form. Exponential is just its standard form. And if you don't remember, if you put it into your calculator, it also gives it to you. But your calculator actually lists it. So if all its fails, put it in your calculator first, then put it in Desmos if you need to do like more with it. That would be a good strategy because your calculator lists them. Like it says lin reg, quad reg, expo reg.
I also get a question
All right, guys, we're going over this in about 2 minutes. So make sure you got all 3 done.
She doesn't want to get into I don't know. It's just actually unfair. Anyways, I think we should do that. Where should we go? Well, I don't think it's allowed to.
How are we all gonna get there?
Stop. We need a texture. She wanted to No.
All right, guys, let's go ahead and go over these. So I'm going to draw popsicle sticks. Oh, yes. Of course, the first one I draw is Neely, and she's not here. Olivia, what is the best fit function for letter B? First off, is it exponential, quadratic, or linear? Right. Shh. It's exponential. What was the function that you got? Good. Raise to the x power. So for this one was one where the r squared was equal to exactly 1, meaning that it was a perfect fit. All right, so if you ever have one that's actually equal to 1, it's a perfect fit. That's your answer. That should also typically be like if you plug in a table to get an equation, you're using regression for that. That's the other way you do it. All right, it should be equal to 1. All right, should be if you're like just trying to find the equation from a table. All right, let's go with James. So C is a little bit different. There were 2 functions that actually fit the best because they both were equal to 1. Their r squared values were equal to 1. What's one of them, James? Exponential was one of them, and what was the function that you got for exponential? So like the actual equation. So if you plug in for a, so if you plug it into, if you take the A and B values that they gave you and plug it in respectively, this should have been about what you guys got. So A was 21051.1, B was about 0.95, and then you raise it to the x power. All right, Riley E, what was the other best fit equation? All right. Adeline, what was the other best fit equation? Caroline, what was the other best fit equation? Ralph, what was the other best fit equation? Yep. I want quadratic. Yeah. We already had exponential. Now I need the quadratic. So what'd you get for the quadratic function? So the actual equation, if you take the parameters, guys, is this. All right. So you also got to actually plug it in to get the equation, guys. Like that's kind of the whole point. All right. Last one, D. Let's go, Kyrie. What'd you get for the last one? Okay. So quadratic was the best fit. All right. And what was the equation? So just for time's sake, it was this. Because I know you're working on it, but gotta move on. All right. So here's what's going to happen. There is an assignment and quizzes for you guys. It is literally past EOC questions, all calculator active. So I went through one of our practice EOCs and I grabbed questions that you could do in Desmos using the skills that we already talked about. So there's 10 questions. All right. It's due tonight by midnight, but you need to go ahead and knock it out now because we're going to go over it tomorrow. All right. So it's in quizzes. It's called Math 1 EOC Desmos Practice. All right. I'll let you guys take your 5-minute break now. Come back. When you come back, you're going to do that assignment. You need to be back in here by 8:40. Yep.
If you can find any, not even, it doesn't have to be perfect, but if you can find any, can you tell me how to look at any extra that can make my grade?
So, extra credit wise, it won't help. Your grades are too low in the other two terms. It really won't help. But, I mean, if you do your work for this one, I can possibly go back and change your grades so that you do pass, but you need to actually get the work done.
Alright.
And you need to stop students in class. So, that's like the best I can tell you.